Hello, ladies and gentlemen. Today we're going to be talking about the final transformation of the four transformations in this unit, and those are called dilations. So what you're going to need is your guided note or foldable from me, a pen or pencil, and a composition notebook. So first we should probably talk about what a dilation is. It's a type of transformation that enlarges or shrinks a figure from a given point or from a center point. And remember that dilations create similar figures. This is the one transformation that does not create congruent figures, okay? So if we look at the left two sets of bullet points, if we dilate the triangle ABC that's given in the picture by a scale factor of 1/2 with the origin as the center, we're going to be half as far away from the origin. And our scale factor, if it's less than 1, means that our image from our pre-image is always going to be getting smaller. And then on the right-hand side, if we talk about dilating the triangle ABC by a scale factor of 2 with the origin as the center, we're going to be twice as far away from that center or from the origin. And when our scale factor is greater than 1, that means that our image is going to get bigger or get enlarged. So let's look at how we would actually do that. First, let's talk about if we shrink it over in this box over here. So let's find the ordered pairs of the pre-image points A, B, and C. The ordered pair of the pre-image A point is 2, 1. And then the ordered pair of point B is 2 up, let me count, 1, 2, 3, 4, 5. And then the ordered pair C is 1, 2, 3, 4, 5, up 1. So what we're going to do to these ordered pairs in coordinate form is we're going to actually multiply them by our scale factor, which is 1/2. So we're going to multiply the x coordinate and the y coordinate by a scale factor of 1/2. So we're multiplying 2 by 1/2, which gives me 1, and 1 times 1/2 is 1/2, or 0.5 if you want to write it as a decimal. So point B, if we multiply 2 by 1/2, we get back 1. And then if we take 5 times 1/2, we get back 5/2, or we can write that as 2.5. And then point C is 5, 1, so if we take 5 times 1/2, we just said that was 2.5, and 1 times 1/2 is 0.5. So now let's plot those points. So we go to the right one, up 1/2 for A prime, then we go right one, up 2.5 for B prime, and then let's plot C prime, so we go over 2.5, up 1.5, and that's going to be my new C prime. So see how this image is shrunk about half as much, or exactly half as much, as the pre-image or the black triangle from our picture. Okay, so we're going to do the same thing in the right-hand box, but now we're going to dilate it by a scale factor of 2, which means that it's going to be enlarged. Here I'm going to pick a different color. Let's do blue. So the original or pre-image points A, B, and C are the same, so we can copy them from the previous little box on the left. A was 2, 1, B is 2, 5, and C is 5, 1. So A double prime then, we're multiplying by a scale factor of 2 this time. So my A double prime is going to become 2 times 2, which is 4, 2 times 1, which is 2. B double prime is going to become 4, 10, excuse me, because 5 times 2 is 10. And then C double prime is going to be 10, 2. So let's plot those points. So we go to the right, 4, 1, 2, 3, 4, up 2, 1, 2. That's A double prime. B double prime is going to be 4, 10, 1, 2, 3, 4, up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's B double prime. And then C double prime is going to be to the right 10, up 2, which would be right here, C double prime. So whoa, that was not a straight line. My big triangle or my large triangle is going to be the blue triangle on my picture from the black one. So that's dilations. Let's look at some more examples. So we need to ask ourselves with dilations, what is really happening? So if this little blue triangle in my picture is my pre-image or my original image, what we're talking about is from our center point, the distance of each point to the center, what that is. And then when we dilate it, we're looking at the distance of the new point and we're doubling the old one. So if my original distance was from here to here to the center, from this point to the center, when we're dilating it, if in this case we're enlarging it, we're doubling it, so we're making sure that this distance to the center is double what the original was. Or if we were shrinking it, it could be a half or a third or something like that. So we're talking about the distance in relation to the center point. That's what's going on as far as like how we're shrinking or enlarging this. Okay, so for the first example, we're going to be dilating the triangle JLK by a scale factor of 2. So just like we did on the front of your foldable, we're going to be multiplying the coordinates of each of these points by a scale factor of 2. So the original ordered pairs of J, K, and L are negative 3, 6, negative 1, 1, negative 3, 1. So when we multiply those by 2, J prime becomes negative 6, 12, K prime becomes negative 2, 2, and L prime becomes negative 6, 2. So now we need to plot those points from the origin. So if we go left 6, up 12, which would be roughly up there. So I'm going to plot that point up there, and that would be J prime. Then let's plot K prime, which would be left 2, up 1, 2, which is about right there. And L prime would be negative 6, up 2, which is right here. So this would become my new image or my new triangle. So if I dilate the next triangle, in example number 2, we have the triangle ABC by a scale factor of 1/2. We're still multiplying the original ordered pairs coordinate points of A, B, and C. So my original A, B, and C ordered pairs are 0, negative 4, 2, 0, and 4, negative 4. So if I multiply each one of those values, or each x coordinate and y coordinate for each point, I'm going to get A prime is 0, negative 2, B prime is 1, 0, and C prime is 2, negative 2. So let's plot those points. So 0, negative 2, this become my new A prime. B prime would be 1, 0, which there it is, B prime. And then C prime would be 2, negative 2, which is right here. So this little triangle is our new image. So now we have to describe the dilation as to what's happening. So in this picture, we need to figure out, first of all, what the pre-image is and what the image is, so what we're going to. So what are we mapping to? So our image, or sorry, excuse me, my pre-image is the tiny triangle, and my image, or the after, is the one with the prime. So the triangle Q prime, R prime, S prime is this triangle behind the tiny one. So we're going from the blue triangle to the red triangle. So let's pick an ordered pair or pick a point, so we can pick Q, S, or R. I think the easiest one to read the ordered pair or to see the point is R. So let's look at R to R prime. So we just need one point. You don't need to do every single point. Let's just pick one. So let's write what R is. R's ordered pair is negative 1, up 1, 2, 3, 4. And R prime is to the left 1, 2. So we're mapping to R prime, which is negative 2, up 1, 2, 3, 4, 5, 6. Let's say 7, 8. So it's roughly at negative 2, 8. So how we're going to find the dilation, so in the last two problems, we've multiplied by a scale factor to get to the x and y values of the prime point, right? So we multiplied by some number. So we need to come up with an equation that can help us figure out what that is. So pick your x or your y. I'm going to pick my x value, and let's set up an equation. We're saying we're taking -1 times some number, so let's call it x or y or a, b, c, whatever you want to call it, and we're equaling it to what our output was, which is the new x value in my r prime point, which is -2. So in order to solve for this, we need to divide by -1, and we get x is equal to a -2 divided by -1, which is 2. So let's see if that's true, if we're dilating by a scale factor of 2. So let's pick another point just to double check to make sure that we did this right. So if we look at the S points, so S is -1, 0, and it's mapping to S prime, which is -2, 0. So how I got from S to S prime was I multiplied each value in the ordered pair by 2. So that holds true. And we could definitely triple check with point Q, right? So in order to set up this equation, all we needed was one ordered pair. So we could have picked Q, R, or S, but if you want to do all three to make sure that you're finding the right scale factor, that's perfectly fine. So let's describe the dilation in words. So the triangle dilated by a scale factor of 2. So this is my answer. So far in the 3 examples and the 2 examples on the front of your foldable, we've talked about dilations with the center being the origin. So what do you think would happen if the dilation was had a different center? What if the dilation was dilating an image from a point rather than the origin? Let's try to figure out what would happen to that pre-image and image. Okay, so our last example for today. We want to dilate the triangle ABC by a factor of 4. Sometimes they'll just say k equals 4, which means a scale factor of 4. So depending on how the problem can give it to you, they can say by a scale factor in words of 4, or sometimes they'll say dilate with k equal to 4. So that's all that means. But this time, instead of using the origin as a center of dilation, we want to use the point -12, -10. So -12, -10 would be right here. So we want this point to be my center. So remember when we talked, what's really happening with dilations? We're talking about the distance away from the center. So if we look at point A, for example, we're going up 2 to the right 2 from the center to point A. So that means that we're going to have to go that distance 4 times because we have a scale factor of 4, right? So we're going up 1, 2 to the right 2. We've counted that twice now, so we just need to do that distance or that step 2 more times. We should have 4 steps. So up 1, 2 to the right, 1, 2, and up 1, 2 to the right, 1, 2. So this point is my new A prime. So if you think about it, our steps should be how many scale factors we have. We went up 1 step, 2 steps, 3 steps, 4 steps. So now let's count the distance from the center to point B. So we go up, I'll do it in a different color here, 1, 2, 3, 4, 5 to the right 2. From that point we go up 1, 2, 3, 4, 5 to the right 2. That was only 2 steps, so we need to go 2 more. Up 1, 2, 3, 4, 5 to the right 2, and up 1 last step. 1, 2, 3, 4, 5 to the right 2, and that will be our new B prime. And last but not least, our C prime. So we're going up 2 to the right 1, 2, 3, 4, 5. So go up 1, 2 to the right 1, 2, 3, 4, 5. Up 1, 2 to the right 1, 2, 3, 4, 5. Not quite there yet. We need one more step. So up 1, 2 to the right 1, 2, 3, 4, 5. So that's my new C prime. So my new triangle, A prime, B prime, C prime, is right here, this green triangle. So we dilated by a scale factor of 4 with the center as negative 12, 10. So let's, just for fun, write out these ordered pairs from start to finish. So let's write what happened with the ordered pairs from A, B, C to A prime, B prime, C prime. So A was a negative 10, negative 8. B was a negative 10, negative 5. And C was a negative 7, negative 8. And then we went to A prime, B prime, and C prime. And A prime was a negative 4, comma, negative 2. B prime was a negative 4, 10. And C prime was 8, negative 2. I want to thank you all for taking such good notes, and I shall see you soon.